Hi, I will show you how I created this hairstyle from hair library. First I will go into quick overview, then I will go into more detail, and hopefully soon I will make other tutorials about different presets from hair library. Okay, so in here we start with this grid mesh. If I show you, this is how it looks, and we spawn strands from this edge marked as sharp. And from this mesh, then we spawn two strands, two hair systems. So we get like a background layer, the red one, and then flyaways, the green one. And let's disable the flyaways, and I will go explain each deformer quickly. That is creating the first layer. So we start from strand generation. If I set this to maybe 6, we get 6 strands. And subdivision steps is adding more points to each strand. So then we are sliding points towards the bottom. So we get bigger density in here. And later when I add noise, we get a smoother result thanks to the increased density in the bottom. Then I am pushing out the strands slightly. This is needed for the curls because, for example, if I disable push out, you see the curls are moving the hair into the head. So I am pushing the strands, adding curls, then aligning tilt to the surface like so. Then we are breaking the even look with bit of noise. Then I am tapering strands like that, and I am then assigning UVs. So currently I think this is using default UV box number 0, but I can manually override this with this button. And if I use number 0, you see it is bit too dense, number 3 is too thin, so number 1 and 2 actually are good enough. You can shift click to pick multiple UV boxes like that. Okay, so we use number 1 and 2. Then I am adding a bit of randomized tilt. So instead, without it, strands go perfectly aligned, but with added random tilt, they are slightly tilted like that. Then I am pushing strands slightly, then pushing them again. This second push out is actually to add a bit of volume in the bottom part, like that. Then I smooth the strands slightly, and set factor is used. This is black and white gradient attribute that is used in the hair shader. I can show you this factor attribute. And basically it is used in the shader to color roots and tips. So if I go to hair shader, I can change the root color, or I can change the tip color. And I can customize this gradient using this set factor. So in this case, I am using gradient like that, and randomize this slightly like that. Then I am on top of that using system color to add a bit of orange overlay on top of the strands. So this system color is used in here, and it is mixed in additive way on top of the base color. So if I add black color to base color, it won't change the base color at all, but the oranges color will be mixed with base color, so the result will be like that. So without and with added system color. And lastly, I am adding a bit of trim for hair roots. So if I increase this trim, so it will be easier to see, this is the result I get. So it breaks the very uniform look. And this is the base layer. Then the flyaways, they are kind of similar, except they spawn less strands, 44. I am using similar slide of points to the bottom, so that when I add noise, we get smoother result for the flyaways. I am using radius set to taper strands, pushing them out slightly. Then in the UV region distribute, I use those two UV regions. So if I use different UV regions, it doesn't look that good. And then I am again randomizing tilt slightly with add tilt, pushing them even more so they are not clipping with the layer below. And again, system color is used to add a bit of variation to the hue and to the value. And system factor is then added to make the hair slightly brighter. So you see in this tip value is set to 1, and this way we get slightly brighter color than the background color. Okay, so now I will go into more detail about the whole setup. So let's go to the first layer, and I will disable everything except strand generator. And maybe before I change anything in here, I will actually explain how to create this grid mesh that will guide the hair strands. So you can use simple plane for that. And I will rotate that 90 degrees, scale down, subdivide like so. The less geometry you have, the easier it will be to work with. So let's say you adjust this to match your character head like that, and then you will want to mark first edge as sharp. In object mode, run strands from grid surface, and that's it. We have the strands generated like that. I can pick one UV region to make it easier to look at, and I will adjust the grid surface to make it easier to see some sliders, how they work. So let's move this up like that, and maybe let's add a bit of subdivision on the right. Okay, so now if I go to the strand generator, you have few sliders, amount of strands, amount of subdivision of the points. So we get like by default 2 points, then 4, then 8, 16, etc. And there is slider for uniform point spacing. So if I set this to 1, we get uniform distribution of the points. If I set this to 0, you see the points go to the top because the grid mesh is denser on the top. There is similar slider for uniform strand spacing. So if I disable uniform strand spacing, they go to the right, again because the mesh topology is denser on the right. And there is option to randomize spacing, and also there is this hook first segment. So without it, when I move the first segment, you see this is not quite precise. But if I enable hook first segment in the strand generator, we get a bit more control, especially with this first loop. Okay, so this explains the strand generator, and in here, to make it easier to see, I will generate only 7 strands, maybe enable taper and align tilt, so now we get something like that. Okay, so we generate a bunch of strands, then I am using the slide points to add more density in the bottom. The way it works, this is controlled with this influence range mask. If I preview that, you see we get more points in the black spots. So when I reduce tip value to 0, we get even more density. I can also adjust the root value. So if I reduce root value to 0, we get more density on the roots. And okay, so then I add push out, just like I explained previously. This push out is for the curls, so the curls do not move inside the head. The push out is quite simple. It is using this kind of mask, so black parts are not affected by the push out. Then the curls, they have quite a bit of sliders, So there is the frequency. I actually randomize frequency, but it is almost not visible. So let's add curls in here. And first, if you have realistic head scale, set the global scale to 0, 1. Now we do not have enough resolution on the strands, so I will subdivide them like 4 times. Go back to curls, reduce frequency, and we get something like that. So anyway, I wanted to show you the randomization, how it will look like if I increase that. So this way it can look more organic compared to the without randomization. Okay, so I am then adding some mask on top of the amplitude input. So in this case, I am adding this length mask. This length mask makes it so that the shortest strand in the back will receive 0 amplitude. Then I am using offset gain mask on top to move this gradient slightly forward and randomize to kind of bit randomize the radius like that. Then we have the influence range for the whole curls effect. So you see the first half, top half has 0 effect of the curls. If I increase that, we get this kind of effect, which is not what I want. I want the first half to have 0 effect, then I increase this effect to 100%, like you can see, and then on the endings, I go back to 0. So we do not have curls effect on the endings. Then I enable a bit of gravity. Maybe it will be easier to see again on the left. So without gravity, we have uniform frequency. With gravity, we move the curls toward the bottom. And you can see we have not enough resolution actually in the bottom. So this is where the slide points can help. So above curls, I would search for slide points. And now it looks even worse. It is because if I preview this input influence range, this gradient is flipped. So I will flip this again. And now you see we get black color on the bottom, meaning the points go to the bottom and we get smooth result. And then we get phase offset. If you want to play with that, project normal, I do not use that. But if I enable that, the curls will go only in the normal direction. And that's almost everything. I also enabled to use global time without global time, with global time. It will be easier to explain on a simple image. So let's say this is the character head with 2 hair strands with curls. So one curl, another curl. So you see they have two bumps, but they are not aligned. And with global time, I made it so that those bumps will be aligned like so. So in some cases, you may prefer to use the global time. And that's it about the curls. Then I have the align tilt, so without, with. And one interesting parameter is the use shortest rotation. It doesn't do much here, but the way it works, let's say we have a haircut rotated like that, and surface normal goes like that. So align tilt will move the and rotate card to the left. But let's say we have haircut that goes more to the bottom, to the center of the head. So now you would have to rotate this like so. But if you enable shortest rotation, then instead the curve will rotate toward the inside of the head, because in that case it will still kind of face parallel to the surface, like so, except it will be facing inside. But in most game engines do not care if you have properly implemented double shaded material, then it usually doesn't matter if your normal is facing outside or inside. they both should look the same. Except Blender. Blender double-sided doesn't like back-facing faces. So for Blender, I would disable the use shortest rotation. So this way, cards normals will always face outside. Then I am adding bit of noise. So maybe to make it easier to see, I will disable curls. And we get boring, flat-looking hair. With noise, we can break this uniform, boring look. And again, I will explain this in more detail on the left. So let's add noise. And for default size of the head, I would set global size to 0,1. Disable uniform amplitude, per strand amplitude to 0. So this is very boring and artificial looking. We want to add a bit of flow to the hair strands. You can do this with the uniform noise amplitude. So we get something like that, but the frequency is a bit high. And now we get something like this. So we get a bit of flow added to the hair strands. I can maybe play with the seed value to find something I like. There is also a nice parameter, flatten along normal. So this way the noise won't go too much inside or outside of the surface if you don't want this. So usually I would play with the sliders until I find the flow that I like, but this still can look a bit artificial and too parallel, too perfect. So this is when you want to maybe add a bit of random noise per strand to break this very uniform look. So you can increase then per strand amplitude to get this kind of effect. Now just do not overdo this, or it will become like look too messy. So usually I will enable per strand amplitude, and to prevent this from looking too random, I would mask this per strand amplitude with the randomize mask. So you see now only the white strands will receive full amplitude. So without with. So you will still get a bit of flow, the main flow, and then this flow is broken with per strand amplitude. And I can increase influence range, for example, to move the noise mostly to the bottom half. So now the black parts are not affected. Okay, so this is almost everything about the noise. I will enable back the curls. Maybe let's go and bump up density a bit more. And then UV region distribute, as I mentioned, this is telling hair system which that those strands should receive this or this UV box. Shift click to pick multiple UV boxes. And then I am adding tilt. Now the way it works, without added tilt, we get flat looking hair curls. Now I am adding tilt plus 30 degree. So some strands will receive plus 30, some minus 30 degrees. Now, okay, maybe let's reduce density. And they are rotated plus minus 30 because of this flip probability. If I set this to 0, everything is rotated the same way. Okay, so I do not want only plus minus 30, so that's why I randomize this. And now we get values from 0 to 30 or 0 to minus 30. And on top of that, I am masking this with influence range curve. So we get low value of tilt on the roots, and then most of the tilt is happening in the center and on the tip. Okay. Then I am pushing out the strands slightly of the mesh surface so that it is not clipping with the character head. Even if I set this value to 0, it will still move any strand that goes below the surface. It will still move those closer to the surface. Okay, so I am pushing them slightly. Then Now the second push out is more interesting because it is adding bit of volume, but it is not moving all the strands. It is moving randomly every second strand. This is due to this matte mask where I select every second strand like that. And to make it less artificial, and I am also randomizing this push out value. And on top of that, I am using this curve so that the first half is not pushed out. Then I increase the value of the push out with this curve. And we get a bit of smoothing then happening, again using curve like that, so the roots are not affected. Set factor, as I explained, it is black and white gradient that helps to colorize roots and tips. Okay, so let's bump up density. And set factor without randomization, it is just simple gradient with bit of randomization. Randomization, actually, I could maybe actually remove it and add bit of randomization with system color. So system color is just adding random orange color. So if I show you, we are adding random color on top of the base color. And I am randomizing value like so we get bit of variation, like so. So I am randomizing, then adding offset gain, and then I do not want the effect on the roots, so I am using simple influence slider to mask the roots. So the orange color will only happen in the white parts. Lastly, trim. Well, it just trims the hair roots slightly like that. And that is everything about all the deformers for the first layer. Second layer is almost the same, so we are just paving less strands. And the difference between first and second layer is that the second layer is linked to the first one with this subtag. So in the parent column, the second green hair system is linked to the red system with this subtag. If I remove it, you see the green strands are not interpolated toward the red ones because they do not have any parent set. So I will set I could call this actually maybe red, make it easier to explain. And now the green strands are interpolated toward the red ones. And to enable interpolation, make sure you use this button in the second hair system. So anyway, I'm sliding strands just like previously. So I'm sliding them to the black points in here, adding again a bit of noise, then tapering the strands, pushing them out slightly, adding again different UV regions with softer texture, adding randomized tilt, this time plus minus 55 degrees. Then I am pushing them out even more from the first layer, adding a bit of randomized system color on top of the base color, and factor set to add brighter highlights. So this time I increase the tip value, so this second layer is not blending too much. So now it is a bit flat, but if I increase this tip value, it gives a kind of effect of dark on white layers. So that is everything about the breakdown of the hair system. Maybe I can go slightly about the profile. So in the profile, I am adding one extra subdivision to the strands in this direction. So the subdivision you see right now is number 1 subdivision, meaning each segment you see is from the point on the curve. If I want for performance, I do not want to add more points to the curve, but I would add subdivision in the profile. So you see this is now subdivided without adding extra points to the curve. So this way it is a bit faster to calculate the haircuts and then smooth them out with profile resolution. With the resolution in here. And profile resolution is actually subdividing strands in this direction. If I set this to 0, you get flat cards. So as you can imagine, this is doubling the poly count. So sometimes you may want to not use this if you do not need it. Width from UV, basically in the UV regions, if you have narrower UVs, you want also narrower width of the haircut. So this is where you enable that option. Roundness, you can make this rounder like so, or with influence range, you can make it so that, for example, switch the influence roundness to the root center tip value, set root and tip to 0, center to 2. So now we have flat endings, but the bump is only happening in the center. We can uplift the haircuts, stuff like that. And in the other section, in the profile, there is option to simplify strands. If I preview the poly count, right now we are around 13,000. If I enable simplification, I can set maybe like 6 points for the shortest strands, and maybe like 18 points for the longest strands. So now without simplification, with simplification, and if I preview poly count, we went 3,000 lower to 10,000 trees. Now, if you like your result, you can use Ctrl-Shift-H and export haircuts to FBX directly, or you could go with Finalize, that will create mesh version copy of your haircuts. So now you can model them manually if you want, and then go to the Blender file, export, and depending on your needs, I would just remove that and tweak the curve version if you want. Lastly, if you want bit of like manual workflow, you could bake those strands to real geometry, and then you could like manually groom this. Just note that you will lose the procedural setup, so you will no longer be able to like adjust the curve frequency, etc. So I think that covers this hairstyle. Hope you like this. See ya.